Did you know there's a parallel universe in which you live but are unaware of it? Well, this may appear frightening. It's not impossible to find a duplicate of yourself or a loved one in another universe. This is due to the concept of multiple worlds. Despite some scientists dismissing the concept as a dream, it is possible that these parallel worlds exist. In what ways do parallel universes affect you? In this video, we'll look at how scientists have finally discovered the proof of the existence of parallel worlds, as well as many other topics. Have you ever pondered the possibility that life exists in other forms? We're all here because we've all wondered about the mysteries of the universe since the beginning of time. On the other hand, scientists do much more than just hunting down the cosmos for clues to the presence of life in other parts of the universe. They have come up with the idea that there might be other universes alongside ours. The term parallel worlds refers to the idea that there may be an infinite number of universes that are very similar to our own. This idea sounds like something out of a science fiction book or movie, so anyone who has ever read or watched one is sure to be interested. In 1954, Hugh Everett III, a student at Princeton University, came up with the radical idea that there are parallel worlds or universes that look exactly like ours and are connected to them. There are parallel universes and parallel worlds that branch off from our own. In parallel worlds, the world wars might have been different, and dinosaurs might still be alive or have died out. This idea can be used in a lot of different ways. In some possible alternate worlds, humans may have died out completely. A lot of people didn't believe this scientist wannabe's idea. This is because he tried to solve some of the questions left by experiments in the new science of quantum physics, which became known as Everett's different world theories. Scientists have found that quantum physics is the study of matter at the smallest level possible. On a subatomic level, quantum matter behaves in a chaotic way, which is different from how many other things work. Scientists now think that there are more scientific rules at work here that we haven't found yet, even if we don't know about them. Quantum meta-researchers were among the first to notice that some quantum particles, like photons, seem to change their shapes at random. Researchers who study photons say that some of them act like particles, while others act like waves. It's as if you were a solid person one minute and a gas the next. This is called the Heisenberg uncertainty principle, and it is something that happens all over nature. Theoretical physicist Werner Heisenberg said that people could change the way quantum matter behaves just by watching it. I know. Another physicist named Niels Bohr concurred and went even further by proposing that quantum particles exist in all possible states simultaneously. The way they act is changed by what we see, which forces them to choose one state at a time. Everett's many worlds theory could be thought of as an alternative to Bohr's quantum physics paradigm. Everett said that looking at quantum matter creates a real split in the universe, rather than just switching between the states. Because of the many worlds hypothesis and what it means for quantum matter, the universe is actually duplicated and split into several parallel universes for every possible state. Everett's theory says that if you've ever been in a situation where the only possible outcome was death, there must be another world where you did die. This method was especially controversial because it made us question our basic ideas about time. For all of these reasons, Everett's idea was thought to be crazy for a long time. Even Everett's theory has recently gotten scientists' attention after several researchers did thought experiments that seem to prove its theoretical viability. There are also other ideas, like the Everest hypothesis, that try to explain quantum mechanics. Even though there's no evidence to support this claim, string theory says that there are particles smaller than quantum matter. String theory also concurs that there are parallel worlds, but as we move away from the Big Bang, we will almost certainly come across other planets. How? Still, remember that we can only reach so much of the universe in our lifetime. The Big Bang happened 13.8 billion years ago. Ever since, the universe is continuously expanding, cooling, and moving away from its first state. The nearer we are to the rim of the hot Big Bang, the further we have to travel in both space and time to find the origin of everything. If the universe was hotter and denser than it is now, it would not have the qualities we see. On the contrary, there is evidence that cosmic inflation stretched the curvature of the universe to the point where it was difficult to tell if it was flat or not before or during the hot Big Bang. This is because cosmic inflation caused the universe to expand. Then, very high energy pieces, expected to come out at very high temperatures, were blown away. On top of the uniform energy background, the quantum fluctuations that happened during inflation were added, giving a whole new universe the same amount of energy. As inflation goes on, there is a chance that the field will roll into the valley where the inflation stops. Because the universe is growing and making more space all the time, all of these things can happen at the same time in different parts of the expanding universe. As the universe keeps expanding, the field will eventually roll into the valley, stopping inflation. In these areas of what we might call space-time, hot Big Bangs happen. Between these two worlds, there is still inflation, which means that the expansion will never stop. As the universe gets more significant, more space is made. When the field rolls into the valley, it makes more hot Big Bangs and even more universes. Inflation is still going on where it didn't stop, meaning that space is still expanding. Now, you can build up the hot Big Bang with what we know about it and still have a multiverse, creating new worlds all the time that we're always getting cut off from each other by space that keeps getting bigger. The universe keeps making new worlds and having Big Bangs. Even though all of these worlds were made in the same small area of space, there is no way to share information between them. They have nothing in common. Even scientists are not sure that parallel universes are even real. One of the main things they don't like is that you can't test it. However, all of that seems to have changed because of a new test. During the experiment, particles were found that may have come from somewhere else in the universe. In August, scientists went to Antarctica to see NASA's Impulsive Transient Antenna. There isn't much or any radio interference in Antarctica, so ANITA uses a big balloon to hang electrical antennas high in the cold, dry air above Antarctica. High-energy particles from the universe are constantly moving through the air. Even if we could make them, they'd be a million times stronger than anything we've made before. Neutrinos can easily move through the Earth's solid matter because they don't interact with it much. However, objects with more energy are slowed down by the Earth's solid matter. The tau neutrino is a heavier particle that can only be found when it comes from space. If these particles are moving backward in time, this shows evidence of a parallel world. Although several scientists have said that the event found by ANITA is interesting, it wasn't caused by parallel worlds. Instead, they say it was caused by other things. Astronomers who lived long before us have said that our planet is the only one. So, the idea of many worlds isn't one that should be thrown out. If we think there are parallel worlds, how can we find out if they're real? At the very least, if our universe and another universe collided, that would be proof. The cosmic microwave background, or CMB, is the afterglow of the Big Bang, and some theories suggest that when galaxies collide, they may leave behind cold or hot spots on the CMB. If this is true, then high-resolution surveys of the sky should be able to find these strange things. Gravitational waves, which make space-time ripples, could also prove inflation. As predicted by the theory, some telescopes are looking for small curves in the CMB that could be caused by gravitational waves left over from the Big Bang. If researchers can find the same curls in the CMB that they thought they found in 2014, it's possible that there's another you out there living a normal life on another planet. This would prove sci-fi writers right yet again. First, a connection must be made between parallel worlds and black holes and white holes, which are two more strange and scary things in space. A black hole is a terrible thing in the furthest reaches of the universe that eats anything that gets too close. Even light can't get away from the pull of gravity of these dense objects, which are made when two big stars collide. White holes, however, are the opposite of black holes because everything has to go out and nothing can go in. We won't talk about every idea about how white holes form in this video, but how do they work together? White holes could cause several Big Bangs, each of which could lead to the birth of a new universe with different physical rules, both inside and outside the white hole's sphere of influence. Antimatter could be used to make things happen, or time might not be favorable and one way. Most likely, these parallel universes are reflections of our own, with different histories based on the appearance of other quantum states. This proves that quantum superposition is real. Let us know what you think about parallel worlds in the comments area below. We'd love to know your thoughts on this and the implications of what further research could prove.